So yeah, I hope all of you can hear me. If yes, please say yes in the comment box if the screen is visible to you. If everything is going fine, you can say yes. Then we can start our lecture today. Okay, so I hope everything is clear to you. It's audible and it's visible. Okay. So see here, good morning all of you. If you recall last lecture, in what we are doing in last lecture, basically we defined calculus of two variables. Basically, like we have seen how the partial derivatives are to be evaluated, and then we have seen some important results like Euler's theorem. For example, I have told you what's a function, what's a homogeneous function basically, and how to tell the degree of that homogeneous function, correct? So we have defined Euler's theorem, which states that if a function f of x is a homogeneous function of degree n, then basically it tells us the relation between the partial derivatives, correct, and the function. And then we moved on to the concept of maxima and minima in two variables, and then I gave you the working procedure how to find the maximum and minimum of a two variable function, correct? This is what we have seen in yesterday's class. So before going for the next topic, I would like to solve one example which makes you to understand this concept of maxima and minima in two variables in a more emphasized way. So see here, the question I would like to discuss at beginning of today's class is the distance between origin and the point nearest to it on the curve z square is equal to 1 plus xy. Okay, so basically there is a curve z square is equal to 1 plus xy. Then definitely on this curve there are infinitely many points, but out of all those points there will be one point which is very close to origin, correct? So we need to identify what's the distance between the origin and the point which is on this curve which is nearest to the origin. Means, for example, if you see, if I would like to draw this curve, this is origin O, and for example if this is z axis, x, y, z, let us follow the conventional x, y, z rotation anti-clockwise. Let us suppose there is a curve z square is equal to 1 plus xy. Okay, this is a curve. Then definitely there will be one point here, somewhere here, such that this point is close to this origin. Yes or no? So we want to know what is this shortest distance d between this origin and this curve. Okay, so this is the case. So hence this is the first question. Let me solve this question for you people. Solution. If you write the solution for this question, see, points, there are 2 points. First of all, if this point is capital A, then let point on this curve be xyz. Okay, any point be xyz, such that this xyz satisfies this condition because this point A is lying on this curve z square is equal to 1 plus xy, correct? So we have 2 points A xyz and O 0 0 0, correct? So if these are the 2 points, what's the distance between these 2 points? Basically, if I call it as OA, then this is equal to root of x square plus y square plus z square, because you know distance between 2 points x1 y1 z1 and x2 y2 z2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So if you see, if this point origin is my first point and if this point A is my second point, then you could get this particular expression for the distance between those 2 points O and A, and let me call this distance D. Now read the question. And the point nearest to it, if this point is nearest to it, then this D should be minimum. That's all. Because if D increases, that means the point is getting far away from the origin. But if the point is very near to the origin, this distance D should be minimum. Means you need to find minimum for the function. See, the function that you have is OA is equal to root of x square plus y square plus z square. Now see carefully, this point xyz is lying on that curve z square is equal to 1 plus xy, correct? So in place of z square, replace with 1 plus xy. Okay, because this point xyz is on the curve z square is equal to 1 plus xy. So I am replacing this z square with 1 plus xy. So this implies OA is equal to D is equal to root of x square plus y square plus 1 plus xy. Correct? So this is the function for which you need to find minimum now, because this d is nothing but this value, and let f of x comma y is equal to x square plus y square plus 1 plus xy. So this is the case now. So this is the function for which you need to find the minimum value, because if you find the minimum of this means this particular set of x and y where you are getting minimum is the point where this d is minimum, correct? So your main intention is to find the minimum value of this function, and this is a two-variable function. Now let us see how to evaluate the procedure. If you recall yesterday's procedure, if I told you if f of x comma y is a two-variable function, then the procedure to find maxima and minima is, first step, find p and q. Correct? What are p and q? Partial derivatives of f with respect to x and with respect to z. This implies p is equal to partial derivative of this function with respect to x. Partial differentiation of x square is 2x plus partial differentiation of y square is 0, because whenever you are differentiating with respect to x, you will treat y as a constant. So this is 0 plus differentiation of 1 is also 0 plus when you treat y as a constant, differentiation of xy with respect to x is y. So this implies p is equal to 2x plus y. Similarly, what is q? Q is equal to partial differentiation with respect to y. If you carry out that, you will be getting 2y plus x. Now our step is to equate these two equations to 0 and get the points of x comma y. So let us do that. Second step, equating p is equal to 0 and q is equal to 0. This implies 2x plus y is equal to 0, which is p, and 2y plus x is equal to 0. So now these are the two equations that you got to solve for the values of x and y. So if these are the two values, if you simplify this, you will be getting x comma y as 0 comma 0, because if you see, these are two linear equations which are of the form y is equal to mx. So they are both passing through origin, and 0 comma 0 is the solution for this. You can solve these two equations basically. So now this is your stationary point, correct? 0 comma 0. Now what's the next procedure I told you? See, first of all, this is a numerical answer type question, and there is only one stationary point, correct? So straight away you can decide this is the point where this function is minimum. Suppose if there is one more point, you could have calculated RST values, then you might have calculated this RST values at 0 comma 0 and checked for maxima or minima condition. But actually in this case we are getting only one stationary point, and gate questions are in this way where your analysis will get shortened, okay, because this question has to be solved in 2 to 3 minutes on an average. So there is only one stationary point, and since this is a fill in the blank question, definitely there is a minimum for this function, and this minimum exists at this stationary point, correct? So therefore x is equal to 0, y is equal to 0. So what about z? Z square is equal to 1 plus xy. So this implies z square is equal to 1 plus 0 into 0, which is 0. So z is equal to plus or minus 1, which means basically there are 2 points, 0, 0, 1 and 0, 0, minus 1. These are the 2 points which are on the curve z square is equal to 1 plus xy and very close to origin. So the distance between origin to any of these points is 1, because if you substitute these xyz values here, you will get OA is equal to 1. Therefore, shortest distance is equal to 1 unit. Shortest distance is equal to 1 unit. See, if it's not a fill in the blank question, if it has some options, definitely you should go for RST values, which is second derivatives at 0 comma 0. But since this is a fill in the blank question, definitely extremum exists at stationary points, and we got only one stationary point. So which means you can straight away put that stationary point in this expression and you can evaluate the value. Okay, is it clear? Is this question clear to all of you? Why the shortest distance is 1 unit between the origin and this curve? Clear? Because we have a two-variable function and we carried out the analysis to find the minimum of this function. Okay. Is it clear so far? If it's clear, then I'll go for the next concept. If you have any questions at any moment, you can ask me. Is it clear why we are writing this way? I want all of you to respond. See, basically this is a two-variable function. So when we followed the procedure for finding maximum and minimum of a two-variable function, this is what you got. Okay. Yeah, I hope all of you understood? If there is any difficulty, you can write it there. I'll go once again. Yeah, we'll be getting a lot of problems, no issues. And in today's class, we'll be solving almost 20 to 30 previous gate problems, which I made a separate sheet for that. We'll be solving them. So no issues. We'll be revising all the concepts that we learned, and finally we'll be in a good situation to solve questions from calculus. Okay, is that fine? Okay. So I hope all of you are happy with this. It was understood to all of you. So see here. Now we'll discuss something called constraint maxima and minimum. Constraint maximum and minimum. In bracket, you can also write this is called Lagrange's method of undetermined multipliers. Undetermined multipliers. So see here, what is this constraint maxima and minima? Why this concept is really important in engineering applications? See, now for example, if I ask you one simple question before going for analysis, what's the value of, or you can write maximum value of x square plus y square plus z square? Or this, if I tell you this, what could be your answer? Where x, y, z, you can put any values, whatever you like. What's the maximum value of this x square plus y square plus z square? I'm waiting for your answers. What's the maximum value of this function when I didn't put any constraint on this? Means you can put any variable in place of x, y, z. Infinite, obviously, correct? Because as long as you keep on increasing x, and as long as you keep on increasing y, and as long as you keep on increasing z, this value goes to infinite, correct? Similarly, if I ask you, what is the minimum value of x square plus y square plus z square? Yeah, it's infinite, correct, for maximum case. Now tell me for minimum case, what's the minimum value of x square plus y square plus z square? Please tell me the answers. 0, correct? Because you know this value, since all these are square terms, for the minimum of this complete function, each term individually should be 0, correct? So the minimum value of this function is 0 when I didn't put any constraint. Yeah, I'm happy. Many of you are telling 0. It's correct. See here. So this minimum value of this function is 0 when I don't put any constraint on this. Yes or no? But now if I ask you something like minimum value of this function when x plus y plus z is equal to 1, means there is some constraint that is governed. Constraint equation. Constraint means basically there is a restriction. Okay, there is a restriction on the variables such that this x plus y plus z is equal to 1. Then if I ask you what is the minimum value of this function, definitely you can tell me one thing. The answer is not a 0. Correct? It means this constraint equation is changing something. Means it's changing the maximum and minimum of the functions. And these variables are being governed by some constraint equations in real life. For example, if you see, if you want to build a building, actually, you know, if you, as long as you don't have any constraints like money, land, and all, you can build a building. You can build a building which is of huge size. Correct? But when you have money as a constraint, materials as a constraint, then it's really difficult for you to build a big building, but your building size gets constrained. Correct? Similarly, these functions they can have maximum or minimum depending upon these values. Okay. So let us see when these functions in which variables are governed by some constraint equations are there, then how to find the maximum and minimum of that particular functions. Okay, that's why we call constraint maxima and minima, because this maximum and minimum are governed by this constraint equations. Okay, this is called Lagrange's method also. We'll see why this is called this multipliers method. We'll see shortly. Okay, so basically I want to tell you, you know, as long as you don't put any constraint, values keep on going. But if there is some constraint, then definitely the maximum and minimum gets affected. That's what I want you to understand by this discussion, and let us work out on that. So see here, let f of x comma y comma z is the function for which extremum has to be found. Extremum has to be found. extremum has to be found, and phi of x comma y comma z is equal to constant is the constraint equation on variables of f of x comma y comma z. Means basically this f of x comma y comma z is a function for which you need to find either maximum or minimum, and this phi of x comma y comma z is equal to c is a constraint equation. As in previous case we have seen x plus y plus z is equal to 1. So like that, this phi of x comma y comma z is equal to c is a constraint equation which is governing the variables of this f of x comma y comma z. Okay, then the procedure to find max, or else you can say extremum, basically to find extremum of f of x comma y comma z is, okay, so now you got a function for which you need to find the extremum. It can be maximum or minimum, and then you got something like this constraint equation phi of x comma y comma z is equal to c. Then let us see the procedure, how we'll proceed ahead. Okay, then is, I hope this is clear to you. Okay, is, I'm continuing that. First, form the function f of x comma y comma z, capital F of x comma y comma z, basically is equal to small f of x comma y comma z plus lambda into phi of x y z comma c. I hope you can see this c as well. So plus lambda into phi of x y z comma c means basically this function for which you need to find the maximum or minimum plus some lambda into the constraint equation. Okay, so this is the case. 2. Calculate dou f by dou x, dou f by dou y, dou f by dou z. Please make a note, I am writing capital F here. Okay, not small f. Calculate dou f by dou x, comma dou f by dou y, comma dou f by dou z, and equate them to 0. Okay, then what you'll be having? We'll be having dou f by dou x is equal to 0, dou f by dou y is equal to 0, and dou f by dou z is equal to 0. See, if this is looking like a big theory, then please try to catch up to things. If you're not able to understand, definitely after this theory, we'll be working out a problem. So I'll make you understand all these things, like as we done in case of limit. Okay, so see here. So first of all, we'll be framing the function, which is the function for which you need to find the extremum plus this lambda into this constraint equation. Then calculating dou f by dou x, dou f by dou y, and dou f by dou z, dou capital F, and equating them to 0, where lambda is called Lagrange's multiplier. Okay, because basically we are using this to multiply this constraint equation. Okay, so this is called Lagrange's multiplier. Now see, after doing these 2 steps, now we have 3 equations. Dou f by dou x is equal to 0, dou f by dou y is equal to 0, and dou f by dou z is also equal to 0. This is what we have. Now step 3. Equate any 2 sets of equation and form the relation between the variables. A relation between the variables x, y, and z. Lambda need not be a constant value. See here, x, y, and z. 4th step. Now substitute the relation between x, y, and z in phi of xyz is equal to constant and get the values of xyz. Get the values of x, y, and z. See, basically, after getting these three equations, we'll equate two sets of equations. Means we can equate these two first and these two next, or you can equate these two first, any two sets of equations. Basically, you'll equate two sets of equations and you'll be finding the relation between the variables. We'll see how we'll find the relation between variables by equating any two sets of equations. And next, once we get the relation between the variables, we'll substitute that set of, the relation between the variables in this constraint equation phi of xyz, and we'll get the values at which these derivatives are 0 for xyz. See, basically, here we'll get only the relation between variables. We don't get the values of xyz. But now by substituting that relation between variables in this particular equation, then you will be getting the values of xyz. Okay, let it be x0, y0, z0. Okay, fifth step. The point x0, y0, z0 is the point where f of small f of x comma y comma z has extremum. Basically, it can be a maximum or a minimum, and also it satisfies phi of x comma y comma z is equal to constant. Okay, then sixth point, the extremum of the function is f of x0, y0, z0. I'll give you a minute time to take these things, and once you take this, I'll explain it step by step with the help of an example. Okay, so please see here. Firstly, what you're going to do, you'll frame a function which is a summation of the function for which you need to find the extremum plus some constant lambda into this constant, in the sense it need not be a numerical constant as well. So this lambda into the constraint equation phi of xyz is equal to constant. Now once if you form capital F, you will be differentiating the function capital F with respect to x, y, and z and equate them to 0 individually. Now by equating lambda value from any two sets of equation, you will calculate, you will evaluate what's the relation between the variables x, y, and z. Now once you got the relation between the variables, you will substitute the variables in the constraint equation and you will find the values x0, y0, and z0. Okay, so then this x0, y0, z0 is the point where this function has extremum, and also this f of x0, y0, z0 is the extremum value. Okay, so I'll give you a minute time to take this, and once you take this, please say yes. I'll be going to a question and I'll explain you all these points step by step with the help of an example. Okay, so no issues. If you feel some difficulty here, we'll be solving an example now so that you can understand step by step easily. Did you take this? Finished? Then we'll go for the example. Slivarity, sir, can't we know if it is maximum or minimum? See, basically this method is adopted only to find the extremum of the functions for which only there is maximum or minimum. Okay, for example, I'll let you know when I solve example. Means whenever we are applying this method f of x comma y comma, this Lagrange's multipliers method, the function will have only either maximum or minimum. So that's why I didn't mention its maximum or minimum, but I mentioned the word extremum at all cases. Okay. Okay, taken, all of you. Please respond, whoever online. Did you all take this? Okay, so see here, we'll be solving one question. The minimum value of the function, f of xyz is equal to x square plus y square plus z square when x plus y plus z is equal to 1 is dash. Okay, so basically this is the case. Monica, yes, it's correct. If x plus y plus z is equal to 1, we'll find what's the minimum value. But I want you to understand this before given procedure, this procedure step by step. So I am solving this question for you. Okay, so see here, solution. If you want to solve this question, now what is f of x comma y comma z? Small f of x comma y comma z, the function for which you need to find the maximum or minimum. So this is x square plus y square plus z square, because this is the function for which you need to find the extremum value. Correct? Now what's the constraint equation on the variables? Phi of x y z comma c is equal to x plus y plus z minus 1, or you can write equal to 1, doesn't matter, is equal to 0, of course. So now first of all, form the equation f of x comma y comma z is equal to c. In the procedure I gave you, if this is the function for which you need to find the extremum, and if this is the equation phi of x comma y comma z is equal to constant for which you need to find the, for which is governing the variables with a constraint, then your first step is to form the equation small f of xyz plus lambda into phi of xyz is equal to constant. So I am doing that here, forming this capital F, which is f of xyz plus lambda into this constraint equation, basically x plus y plus z minus 1. Okay, now I have formed the capital F of x comma y comma z with the help of a Lagrange multiplier. Now what's the next step? You need to differentiate this capital F of x comma y comma z with respect to x, with respect to y, with respect to z, and then equating them to 0. So if you do that, dou f by dou x is equal to, what's the value? If you calculate dou f by dou x from this function, this is x square term, so 2x plus this is lambda x, so lambda. That's it. Because all of the terms are completely terms of other variables. So whenever you are differentiating with respect to x, all of them will go to 0. Similarly, what is dou f by dou y? 2y plus lambda. Similarly, what is dou f by dou z? 2z plus lambda. Correct? So now we have calculated dou f by dou x, dou f by dou y, and dou f by dou z. Now once we got this, what's the next step? Equating dou f by dou x is equal to 0, dou f by dou y is equal to 0, and dou f by dou z is equal to 0, which means 2x plus lambda is equal to 0, 2y plus lambda is equal to 0, and 2z plus lambda is equal to 0. So which means lambda is equal to minus 2x, lambda is equal to minus 2y, and lambda is equal to minus 2z. So these are the three set of equations that we got. Basically, lambda in terms of lambda. Lambda is equal to minus 2x, lambda is equal to minus 2y, and lambda is equal to minus 2z. Now, equate any two sets of equations. Means, now from these three equations, you can equate any two sets of equations. For example, if I equate these two first, then I will be having minus 2x is equal to minus 2y, which implies x is equal to y. Okay, next. If I equate these two equations again, I will be having minus 2y is equal to minus 2z, which implies y is equal to z. Or you can equate any other equations, it doesn't matter, but you will be ending up with this particular relation between x and y and z. And this tells us the relation between the variables is x is equal to y is equal to z. Means you will get minimum for this function only when all these three variables x, y, z are same. Okay, so that's how, if you go to these steps, we calculated dou f by dou x, dou f by dou y, dou f by dou z, then we equated them to 0. Then by equating two sets of equations, basically we found the relation between the variables, which means we found the relation between x, y, z in this particular case as all these three, x is equal to y is equal to z. Okay, so now once you get this relation between the variables, substitute this relation in phi of x comma y comma z is equal to constant and get the values of x, y, z. So now if x is equal to y is equal to z, put x is equal to y is equal to z in constraint equation, which means x plus y plus z is equal to 1. So this implies, so see here, if x is equal to y is equal to z, if I replace y with x and also z with x, I can have 3x is equal to 1. So this implies x is equal to 1 by 3. If this is the case, what about y? Since x, y, z all are same, y is equal to 1 by 3 and z also is equal to 1 by 3. Correct? So which means x naught, y naught, z naught is equal to 1 by 3 comma 1 by 3 comma 1 by 3 is the point where this function has minimum. Okay, so now what's the minimum value? Therefore, minimum value of x square plus y square plus z square is equal to 1 by 3 whole square plus 1 by 3 whole square plus 1 by 3 whole square, which is basically 3 times of 1 by 9, which is 1 by 3. Okay, so this 1 by 3 is the minimum value for this function x square plus y square plus z square when x plus y plus z is equal to 1. Okay, and I told you this particular Lagrange's method can be applied only if the function has either maximum or minimum. Okay, for example, minimum is a finite value, but if you talk about maximum for this function, when this equation is getting satisfied, the answer is again infinity, because see here, I want to find maximum of x square plus y square plus z square, correct? And what's the equation I have? X plus y plus z is equal to 1. Now see, I can choose very huge numbers where this equation gets satisfied. For example, if my x is equal to 0, then y is equal to 2019 and z is equal to minus 2018. Then the variables is 0, 2019, minus 2018. All of them are satisfying this equation, and which means if you can substitute here, the value keeps on increasing, which means this function only has a finite minimum value but not a finite maximum value. Okay, so in this case, we can apply this method of Lagrange's multipliers to the functions which has only either maximum or minimum but not both. Okay. So this is one such question. So please take this. I hope all of you have understand this. All of you just understood this question. If there is any difficulty, you can talk to me. I'll explain the things again. So far, I need responses from all of you. See, very few are responding actually. If there is some difficulty, you please ask me. I'll explain you again. There is no issues. Clear to all of you? Only 4 people responded. What about others? Still writing the things? Okay. Okay. Fine. So all of you are writing yes. I'm happy for this. So all of you understood this concept. So basically, this is what the concept of maxima and minima. Okay. And before now, after this, I would like to start the concept of integration of 2 and 3 variables, which is basically the chapter called multiple integrals. Okay. So before going further, I would like to give you one simple line. Actually, the concept of total derivative. Total derivative. Okay. Which means whenever there is a function of 2 or more variables, how to differentiate the function completely at a single instant. So see here, if z is equal to z of x comma y is a function then dz means if you differentiate the function completely in a single instant, you will be having dou z by dou x into dx plus dou z by dou y into dy. If there is one more variable, again, suppose if there is one more variable k, x, y, k, dou z by dou k into dk. Okay. So like this function can be differentiated completely as per this rule. And this is what you see in fluid kinematics and all in fluid mechanics chapters as well. So if this is a velocity, then you know there is something called temporal acceleration, convective acceleration, all these things, which is not of importance in this course actually. So see here, dz is equal to dou z by dou x into dx plus dou z by dou y into dy. Similarly, if you have some other variables, you will be writing the consecutive term as well. Okay, so this is how generally you differentiate the functions when it is of 2 or more variables. Then you can write, if suppose if you are differentiating with respect to x, dz by dx by dx by dx at all the 3 instances. Okay, means if I want to make you to understand dz by dx, if I am differentiating this function with respect to x, then dou z by dou x into dx by dx plus dou z by dou y into dy by dx. So this is how you will be integrating the things. Actually, it's a theorem that you could differentiate. Proof is there because you need to convert the functions into implicit and then differentiating all these things. But I'm not dealing in this course. Okay. But with respect to different variables at each instant, you will be differentiating the things like this. Okay. So please take this result. Questions are not being asked on this formulations as well. But now, since we are dealing partial differentiation, I would like to tell you this, since it involves some partial derivatives and it's of importance in some core subjects like mechanical and civil engineering when you're dealing fluid kinematics and all. Okay. So please take this. If you are clear for this, then we'll go for the last topic of this basic calculus, which is multiple integrals, means integrating the functions when we have two or more variables. Okay. Clear so far? So see here, we'll go for normal derivative we'll do only when there is a single variable, and when you want to differentiate a function normally when it has multiple variables, some partial derivatives also gets involved. That's it. Okay. So next. One very nice topic, and also one of the topic which you are very much afraid and you'll be leaving questions in exam as well. Correct? I hope many of you or some of you might be leaving these questions from multiple integrals in exam because they look big in mathematics with equations and all. But actually they are very simple. So let us see the things in this class now. So multiple integrals. Basically, when you are integrating with respect to a single function, then you know how to integrate and all. We have seen the techniques. So what is a multiple integral? What does the physical essence of multiple integral? We'll see in today's lecture. See here. If the integral I is equal to, let me talk about double integrals first. F of x comma y dy dx has to be evaluated over the region bounded by the curves y is equal to f of x, y is equal to g of x is equal to a, and x is equal to b. Then I is equal to c. Means sometimes they'll be giving you some double integral with some function of x comma y here. This can be any function, but basically which is differentiable. Dy dx or the product dx dy doesn't matter. Then if this is the region bounded, then how to evaluate this integral? Let us see this. The main important thing in writing this multiple integrals is you should know how to put limits on these integrals. Okay. If you know how to put limits on these integrals, then it's a very simple thing. We'll know how to, when limits are given, how to calculate this integral value. Okay, very simple. So see here, 0 x y. Now y is equal to f of x. Let us suppose this is something like this. Y is equal to f of x. Similarly, y is equal to g of x. Y is equal to g of x. These are two functions. Okay. Then there is a line x is equal to a and x is equal to b. Okay. So these are the four curves which are basically given like this, and this is the region which is bounded by these four curves, and you need to evaluate some function f of x comma y within this region, where this region is bounded by these four curves. So let us see how to write the limits of integration at first. F of x comma y dy dx. Okay, so see here, dy dx. Now, how to write the limits? This is the main important thing in evaluating the values of multiple integrals. Okay, see here. If this is the function, now see what is the first variable of integration here. This is the first variable of integration, correct? Which is the inner variable as well. What is the first variable of integration? All of you, please respond. What's the first variable of integration that is here? X or y? All of you, please respond. I'm waiting for you. What's the first variable of integration? Y, correct? So when there is first variable of integration as y, consider vertical strip. Okay, If your first variable of integration is x, you can consider horizontal strip. Basically, we'll decide this is dy or dx depending upon the geometry of curves. Okay, and that's why drawing these curves is really important, and that's why I gave you some 10 to 15 graphs in my first and second lectures of calculus. Okay, so see here, when this is first variable of integration, look, when you are integrating, see, suppose if you are integrating this function f of x dx, then you know x is changing from a to b, correct? Which means if you are integrating with respect to x, your variable of integration with the integral adjacent to the function is x limits, correct? This is what you understood from single variable calculus. So if you see now, if your first variable of integration is y, then the limits on this inner integral should be limits of y, correct? Because if you are integrating this function first with respect to y, then this limits on the inner integral should be limits of y. But these limits of y should be in functions of x, correct? So see here, what is the lower limit for this vertical strip? This function y is equal to g of x, correct? So y is equal to g of x is the lower limit for this vertical strip, because wherever the strip moves in between this region, this y is equal to g of x is bounding it, correct? Now what is upper limit for this function? Y is equal to g f of x. Correct? Y is equal to f of x, because similarly how this g of x is the lower limit for this strip, this y is equal to f of x is the upper limit, and this strip can't cross this y is equal to f of x, correct? Now what about x limits? Now x limits have to be constants, because these are the outermost limits of integration. So if you see, x is changing from x is equal to a to x is equal to b, so that's what you write here, x is equal to a to x is equal to b. Okay, so basically this I can be evaluated as f of x comma y dy dx. Y is changing from g of x to f of x, and x is changing from a to b. Okay, see, I considered vertical strip because here my first variable of integration is y. Now we'll see the case, what if the first variable of integration is x? Okay, so please take this. I'll make you to understand how to evaluate these integrals once limits are given. But first of all, I want you to know how to write the limits. Okay. So please take this till here. Clear so far? Okay, so now I hope it's clear to all of you. So if we take vertical strip, okay, Shreya, then what's your question? That's what we have taken. We have taken vertical strip. Now if we have taken a horizontal strip, we'll see what's happened. Yeah, if we consider horizontal strip for vertical strip, we'll get same answer, which I'll let you know when I'm teaching the concept of this one little concept in multiple integrals, which is called change of order of integration. Means if you integrate with respect to y first, which means you have taken vertical strip, or if you integrate with respect to x first with respect to horizontal strip, your answers could remain same. That's what we'll show you shortly. Okay, please wait. We'll go for that particular thing in the next 10 to 15 minutes. So please stay tuned. So y is changing from g of x to f of x, and x is changing from a to b. Now, if you want to change this order of integration, see here. Zero, x-axis, y-axis. Now see here. If I is equal to integration over the region R f of x comma y dx dy, where R is the region bounded by the curves x is equal to phi of y, and x is equal to psi of y, then y is equal to a and y is equal to b. Means if these are the lines, if these are the curves that are bounding the region, then how to write the limits of integration? See here. See, this is the curve x is equal to phi of y. Okay, and similarly this is the curve x is equal to psi of y. sorry, again I'm writing phi here, so it should be psi of y. Okay, so basically x is equal to y square, all these kind of functions where x is written in terms of y. Now what are the other two curves we have? Y is equal to a and y is equal to b. So now basically this is the region which is bounded by these four curves. Okay, so if you see, I is equal to double integral over the region R f of x comma y dx dy. Correct? This is what we have. Function should be in y for x. Yes, see here. If you write I is equal to integral f of x comma y dx dy. Now again doing the same thing. What's the first variable of integration here? What's the first variable of integration here? All of you? What's the first variable of integration here? I think you're taking so much time to press two keys on keyboard, right? What's the first variable of integration here? All of you? X. Correct? So if the first variable of integration is x, what are the limits here on this inner integral? These should be x limits. Correct? Now these should be x limits and these x limits should be in functions of y. So if you consider a horizontal strip here, like this, now see here, this horizontal strip, whenever it is moving from top to bottom, the left hand side is always bounded by this function phi of y. Correct? So x is equal to phi of y is the left limit. Then what about the right hand side constraint? X is equal to psi of y, and since this is the increasing direction of x, we write phi of y in the bottom and psi of y on the top. So x is equal to psi of y. Now what are the limits of y again? Y is changing from y is equal to b to y is equal to a. So y is equal to b to y is equal to a, because I have done a first, a on the top and b on the bottom. So basically this is how you will evaluate this integral. I is equal to integral b to a for y, integral x is equal to phi of x to phi of y to x is equal to psi of y f of x comma y dx dy. Okay, so don't worry if you are feeling complexity at some point in writing the limits. When we are dealing numerical problems, which I made a list of some 20 questions today, we'll be solving questions there with this particular concept of double integrals and all. You will be solving the examples, and you know in practical how to write these limits like 2x, 3x and all these things, 2, 3, 4, all these things. Okay, so no issues as of now. So see here, basically I want you to know how to write limits of integration. Okay, whenever your first integrating variable is x, similarly in the previous case, whenever the first integrating variable is y. Okay, so basically if this is the first variable of integration, then the limits on this integral corresponds to this variable. Okay, similarly if this is the second variable of integration, limits on the outer integral will is the limits of this second variable. Okay, so please take this. Now if you know how to write limits, I will show you how to integrate the functions. Okay, clear so far? Sliver, what is the significance of the result we are having, sir? Basically, the significance depends upon this f of x comma y. Okay, suppose if this f of x comma y value is 1, means this function of x comma y is a constant whose value is 1, then this integral, if this value is 1, this complete integral denotes the area of this integral. The area bounded by this region. Okay, we'll see physical significances depending upon the functions f of x comma y. Okay. I'll give you what are the physical significances now. So please stay tuned. It depends. Pawan Kalyan, it depends what's the function. Like the function is definitely in terms of x and y, but it depends. If this is only x, then this denotes a into x bar, which I told you centroid formulas and all. So if this is x square plus y square, it denotes something called polar moment of inertia, all these things. You might have learned all these terms in first year of your undergraduation when dealing the course of engineering mechanics. We'll see shortly the physical significance of all these things. Okay, so now First of all, let me tell you, if once the limits of integration are known to you, then how to integrate the functions basically. Okay, for that, let me straight away go to an example to show you that. Integral 0 to 2 integral x to x square y dy dx. Now if you want to calculate this value, see here, what is the first variable of integration? Y. So definitely these are limits of y. Y is equal to x square. X is equal to 0, x is equal to 2. So this is the integral that you have. So if you want to integrate this integral now, x is equal to 0 to x is equal to 2. Now see, when you are integrating with respect to y, see this point is really important. When you are integrating with respect to y, you will treat all other variables as constants. And here, of course, there is only two variables, x and y. So when you are integrating with respect to y, you will treat your x as constant. So if your x is constant, your x square doesn't change, it stays as it is. Now, integration of y with respect to y is y square by 2, correct? Within the limits, y is changing from x to x square dx. Okay, so basically this is how you will integrate the functions when it is of multiple variables. You will treat all the variables as constant and you will integrate the variables which are only of this dy. Okay, so see here, x is equal to 0 to 2. This x square is a constant, so I am writing it here. Now, by 2, this 2 is also a constant, I am writing it out. So see here, now there is y square, and y square is changing from y is equal to x to y is equal to x square. So if you substitute upper limit x square whole square minus, when you substitute lower limit x whole square to this whole dx, correct? So which is equal to integral x is equal to 0 to x is equal to 2. If you simplify all these things now, x square by 2 into x square whole square is x power 4 minus x square dx. Now this is integration of single variable, correct? I am telling you, and I know once you know this step, you know how to integrate. But to get this step, I am repeating the procedure again. Whenever you are integrating with respect to y, you will treat all other variables as constants, and that's why I have treated this x square term as constant in the integrand, and I have got this x square as it is without integrating. Now the integration of y with respect to y is y square by 2, and when I am substituting the limits x to x square, upper limit minus lower limit, this x square by 2 is a constant when I am substituting limits of y, so I am writing this x square by 2 as constant. So when I am integrating, this x square whole square is x power 4 minus x square dx. This is what I have. So now it's a simple integration, 0 to 2, 0 to 2, 1 by 2 is a constant, x square into x power 4 is x power 6 minus x square into x square is x power 4 dx. This is what you have. So if you integrate the things now, 1 by 2 into integration of x power 6 is x power 7 by 7 minus x power 5 by 5 within x power 5 by 5 within the limits 0 to 2. So if you substitute 2 here, 1 by 2 into 2 power 7 by 7. What is the value of 2 power 7? Generally, 2 power 5 is 32, then 64, and then 128 divided by 7 minus 32 by 5. Okay, so you can simplify the value, and whatever you get, you can put it here. I think you will be getting something around 5.94. Correct? Yeah, 5.9. Correct. Yes or no? Are you all getting this value? 5.94? Around 5.9? Are you all getting this or not? If you are facing any difficulty in integrating, please let me know. Yeah, 5.94 is correct actually. All of you are correct. Here my Neerja, Gayatri, Livya, Jyotsna, then Shankar, Sanya. Good. I'm happy for all of you. You're getting the correct answers. So see here. Vikas correct. Okay. So fine. This is how you'll integrate basically when there is two variables. First of all, you'll consider the other variable as a constant. Then you'll integrate the things. Okay. So see here. Now, what is the question that we have? Integral 0 to 2, integral x to x square y dy dx. Can x be in y instead of constant? Yes, we can do that. That's what I want to do now. I told you something. There is some concept called change of order of integration. Change of order of integration. Change of order of integration. So now see here. Here we have integrated this function x is equal to 0 to x is equal to 2, where y is changing from x to x square y dy dx. Correct? This question we have integrated with respect to y first, and we got the answer something around 5.94. Correct? Now let us calculate this same question by changing the order of integration. And generally, I am telling you this change of order of integration concept is really important in GATE. Until now, many questions have been asked already. So see here, if there is a function like this, y is equal to f of x to y is equal to g of x, f of x comma y. Don't confuse between this f and this f. This is just a limit, or let me write this as some other variable, h of x. Okay, so h of x to g of x, basically two functions, and x is changing from a to b. F of x comma y dy dx. If you want to change the order of integration of this integral gets converted to f of x comma y dx dy. X is equal to phi of y to x is equal to psi of y, and y is changing from c to d. Means if you want to change the order of integration, your integral changes like this. And if you see one thing clearly, one very important thing, if you see clearly, this limits h of x and g of x are completely changed. Yes or no? Means it's not like repeating the same limits here. Okay, please remember, in one with respect to first variable as y, if you have some limits, then definitely with respect to x, your all four limits gets changed. Okay, you can't dump these limits here as usual. Okay, your answers will change. Okay, so please take care of this. Now let us try to change the order of this integration. To change the order of this integration means basically the integral which is in this form, to convert it into this form, we should do the following sequences, which I am explaining through this example. Now, what are the equations that are involved here? Y is equal to x, then y is equal to x squared, x is equal to 0, and x is equal to 2. Correct? These are the lines, these are the things that we have here. Now let us do the things. 0, x, y. Okay. Now, what are the curves? Four curves that are involved here. Y is equal to x, y is equal to x square, then x is equal to 0, x is equal to 2. These are the four curves. Okay. So first of all, if you want to change the order of integration, from the given limits, you need to identify all the four curves. Okay. Since this is first variable of integration, then definitely limits on this integral sign are limits of y, which means here is the first limit of integration, first variable of integration is y. These are the limits of y. So I have written y is equal to x and y is equal to x square are two functions that are bounding this region. Similarly, x is equal to 0 and x is equal to 2 are other two functions. Correct? Now, let us try to plot these four curves. Okay, let us try to plot these four curves. How does y is equal to x looks like? I told you, I have given you graph of y is equal to mx. So you know y is equal to x looks something like this. Okay? I hope it's not a straight line. So let me draw it. Something like this. Okay. So y is equal to x. Next, we have plotted this curve. Next, what is the next curve? Y is equal to x square. If you know, the curve y is equal to x square looks something like this. Correct? Y is equal to x square. Of course, it has on the left hand side as well, but we are interested only in the region which is getting bounded. Correct? So this is y is equal to x square. Now x is equal to 0 is the y axis itself. X is equal to 2 is somewhere here. If you see, the point of intersection of these two things is something like this. So x is equal to 2 could lie somewhere here. So basically, if you want to change the limits, you will be changing it as considering dx. This time you should consider horizontal strip. So x is equal to y and x is equal to root y. Okay. So basically, if you see, this region should also include these particular parts. So I am considering only this first case as of now to show you just the change of order of integration. This x is changing from y to root y. and this y is changing from 0 here to maximum of 1. So 0 to 1 x square y dx dy. Actually you should write plus this part as well, but I'm not considering it for the time being. I would like to let you know this by solving this question, by solving another example for you. Okay, but this is how you will plot the curves and then decide which curves to write as limits. Okay, so basically we'll look at this example in a short moment. For the time being, you take this, then we'll go for some example questions, solving of some questions. Okay. So now see here. Okay. So with this, I would like to close the concept of multiple integrals in two variables, and later we'll visit for three variables in a short time. But now for the time being, I'll let you solve some problems which we thought of showing you in this class. So I'll continue back the concept of table integrals after solving the questions that we made to understand all these concepts. Because after solving questions on mean value theorems, we didn't visit the questions again. So I want you to introduce some questions, some 20 good questions of gate to solve at this moment, so that you'll understand all these concepts right now. Okay, so going further. They coincide at x is equal to 1. Yes, see here. Okay, so now we'll be solving some questions on calculus that we learned so far, and then I'll go back to the concept of table integrals, where we'll be solving some short questions. And these 20 questions involve all the concepts right from the limits to the concept of multiple variables till the concept of change of order of integration. So I would like to, before solving these questions, I would like to suggest you, so please solve these questions on your own before I give the actual solution on board. Okay, and please tell the answers. Clear? We'll show you how to change the order of integration with more appropriate examples in this worksheet. So please stay focused. Okay, clear so far? We'll solve these questions. Is that okay for you, all of you? We are solving these questions. Okay, is that clear? We'll be putting more appropriate examples for solving this change of order of integration now in this worksheet. So please start solving this worksheet now. I'll be solving along with you. So I suggest you, please don't wait till I give you the answer. Try it on your own and let's work out it together. Many of you are online, but only few are responding. What about others? Not interested in solving questions? You want me to teach theory, so on, like some story? See, you know, in GATE examination, learning concepts is equally important as solving problems. Okay, so please let us do this, all of you. So tell me, what's the value of this integral now? See, all these 20 are previous GATE problems. Okay, they were asked in different years in different disciplines in GATE examination. So please solve. And I'm waiting for the first answer. Okay, 2 pi by root 10. Sliva, option A, Mahesh, Kadari. I hope all of you are correct. So let us try to solve this question. Solution. Okay, yeah, I hope all of you are correct. I'm happy for you, Sliva, Livia, Mahesh and all. So see here, solution. What is I that you have? Integral 0 to 2 pi 3 by 9 plus sine square theta d theta, correct? This is what the question we have. And if you remember, Vaishni, Maunika, Naveen, all of you are correct. So see here. If you remember, I gave you something which is similar to this when teaching the concept of definite integrals. You remember integral 0 to pi dx divided by a plus b sine square theta and all these things. So let us recall the things. So this can be written as 2 into integral 0 to pi 3 by 9 plus sine square theta d theta, because I gave you a property, if you remember, integral 0 to 2a f of x dx is same as 2 times integral 0 to a f of x dx if f of 2a minus x is equal to f of x. I gave you this property, if you remember, correct? During the concept of definite integrals, I gave you this property. So if you see here, this 3 is a constant and 9 is a constant, so there is no issue so far. But here, if you put sine of 2 pi minus theta, sine of 2 pi minus theta is minus sine theta actually. But because of this square present, there's minus sine theta whole square is again sine square theta, which means this particular combination of f and 2a is satisfying this condition. So we can write it like this, correct? So what's the integral we have now? 2 into integral 0 to pi 3 by 9 plus sine square theta d theta. So if you bring this 3 out as a constant, 2 into 3 is 6 into integral 0 to pi d theta divided by this 9, which is here, can be written as 9 cos square theta plus 9 sine square theta, correct? Because if you take 9 common, you have cos square theta plus sine square theta as 1 plus sine square theta. So this is equal to 6 into integral 0 to pi d theta divided by 9 cos square theta plus 10 sine square theta. Sine square theta. This is the integral we have, and I gave you one formulation for this kind of integrals. Integral 0 to pi d theta by a square cos square theta plus b square sine square theta is equal to pi by ab. I told you to remember this result because this result is going to save you a lot of time in examination, and during the concept of definite integrals, I gave you the proof of this as well, if you remember, correct? So now if you see, yeah, which is pi by ab, correct, nature. So the answer for this particular integral, which is here, is 6 into pi divided by, now what is a? If you compare, a square value is 9, so a value is 3. If you compare, b square value is 10, so b value is root 10. Okay, so if you simplify now, we have 2 pi by root 10 as the answer for this, which is option A. Many of you told correct. I am happy for this. You are getting the concepts. Okay. Clear so far for this question? Any issues with this question? Basically, first of all, this 2 pi you have split it into 2 because we know the formula only when there is pi here. Yes, Sushant, you can ask what is the question? What's the doubt that you have? It's a doubt in this question or you have a separate question? Okay, I'll be providing the contact you later. Please wait, Sushant, kindly. Let us finish off the things first. You can contact me. I'll be providing you some contact this time, so you can access me for doubts and all. So please stay here. Is this question clear so far? Is this question clear to you? See, the main interest in bringing out this 2 is because we have a direct formula for this kind of integration. No, limits are not in a to b. Limits, this a and b basically comes from here. A square cos square theta plus b square sin square theta. Okay, clear? So see here. Yes. Okay. If you are clear, please respond. If you have some issue, please talk to me. Is it clear to all of you? If you are okay, I'll go for next question. But I'm getting only 3 yes. Well, then what about other 70 people? I think 97 people are on live. So please see here. If you say you are clear with this, then I'll go for the next question. Is it okay? Okay. Then this is the next question. Please solve this. So please solve this question, all of you. Okay, Shankar, Ganesh, Seisha. So please solve this question, all of you. All these are previous gate questions, okay? I have set some 20 questions, so all these 20 questions are previous gate questions. A, pi cube by 24. Let us wait, Kamaluddin, if some of us get A. Because generally, I don't remember the answers, so I need to solve the questions with you. Okay, so I can't decide whether if one is telling that question, it's correct or wrong. Okay, so many of you are telling pi cube by 24 as the answer. So let us confine to that shortly, and let me solve this question. So solution. Let sine inverse x is equal to t. Then what about 1 by root of 1 minus x square dx? This is dt. In definite integrals, if you are substituting something, definitely you should change the limits, correct? So let us change the limits. Lower limit. First of all, I am changing the lower limit. We have x is equal to 0. This implies sine inverse of x is equal to t. So this implies sine inverse of 0 is equal to t. So t is equal to 0. Correct? Next, upper limit. We have x is equal to 1. So this implies sine inverse of 1 is equal to t. So this implies t is equal to pi by 2, because sine 90 value is 1. So these are the new limits for the integration. So after substitution. So substituting all these things in this integral, therefore I is equal to integral. Now for 0, you got the corresponding limit as 0. For 1, you got the corresponding new limit as pi by 2. So if sine inverse x is t, this is t square, and this 1 by root of 1 minus x square into dx can be taken as dt. So now it's a simple integration, which is t cube by t within the limits 0 to pi by 2. So this 1 by 3 is a constant. So pi by 2 whole cube is pi cube by 8 minus 0. So which is pi cube divided by 24 is the correct answer. Okay. So option A is the correct answer. Yes. I'm happy for all of you. Many of you are telling the correct answer. People who didn't get the answer, you please follow these standard steps. Okay. Clear? Can I go for next question? Is that okay to all of you? Or any issues so far? Can we go for next question? I want all of you to respond, okay? Since we are solving questions, this session could be a bit interesting and motivated, okay? Okay. So this is the next question. So please solve this question and tell me the answer. All these are gate questions, okay? Previous gate questions. So please solve. Okay. Nayanda, Paveen, Maunika, then Neoja, Jyotsna, Seisha. I'm happy that it's clear to all of you. So please solve this. Answer is B for this question. Nagsai, you mean answer is B for this third question? See, many of you are asking me for a book. Which book to is it? Suggest some book for this calculus and all. I would like to suggest one very good book. As I mentioned in earlier classes also, there is one book called Higher Engineering Mathematics by B.S. Gravel, which is a very good book in mathematics. You could visit that book. And there is one more book for applied mathematics, like applying all these equations in physics and all. That book is by Erwin Kwasik. Actually, I would like to give the name of this person because it's difficult for you to remember this. There is one book called Advanced Engineering Mathematics by this person, Erwin Kwasik, which is also a really good book in mathematics. Okay. Okay, is that fine so far? Can we move ahead? What's the answer for this question? I hope you are solving. Okay, D means 4 by pi is the value of R and 16 by pi is the value of S. That's what Sliva is telling. Okay, let us see Sliva. Let others solve this question in a moment. I got only one answer. C, 4 by pi and 0. Vamsi, you got a different answer. C. Let's see which answer is correct. How many are online actually? nearly 60 people are online, but only few are responding. Answer is D. Okay, there are 2 D's. Okay, let me solve this question actually. So solution. What is C? Okay, 1 D and 1 C is coming alternatively. So let us see. What is f of x? R into sine pi x by 2 plus S. Correct? So what is f dash of x from this? R is a constant. So R into differentiation of sine pi x by 2 is cos pi x by 2 into inner derivative is pi by 2 plus, since given s is a constant, the differentiation of s with respect to x is 0. So this implies f dash of 1 by 2 is equal to R into, if you put 1 by 2 in place of x, this is pi by 4, because pi by 2 into 1 by 2 will give you pi by 4. So cos pi by 4 is 1 by root 2 into pi by 2. So this implies, see, f dash of 1 by 2 is given as root 2. So root 2 is equal to R into pi by 2 root 2, which means if you multiply, you will be getting the value of R as 4 by pi. Correct? So if you see here, both R values are 2 by pi, which means these two options are wrong, false. Correct? But now both C and D have 4 by pi as value of R. Now let us integrate this function. Okay, let me use next page for that. F of x is equal to R sin pi by 2 x pi x by 2 plus S. Correct? So let me integrate this from 0 to 1, f of x dx, because the value of this function when integrated between 0 to 1 is given here, which is 2R by pi. So let us do that. Integrating this function. Okay. Integral 0 to 1 R into sin pi x by 2 plus x dx is equal to, what's the value it's given here? 2R by pi. So 2R by pi. Let us simplify the things now. This implies if you integrate this, R is a constant, so R into integration of sine of pi x by 2 is cos of pi x by 2 divided by pi by 2, because this pi by 2 is an inner integral, of course with a minus sign, because integration of sine is minus cos, plus Sx within the limits 0 to 1 is equal to 2R by pi. Now let us solve this. What's the value of R that you have? R value is 4, something we got just now, 4 by pi. Okay. So 4 by pi into this pi by 2 is in the denominator. So let us retain this here. Pi by 2 into this minus sign is also here. So let us put this. Now 1 when you substitute, this is cos 90. So this is 0 minus, when you substitute 0, cos 0 is 1. So this is what we have for this term, plus S into, again substituting the limits 1 and 0. 1 minus 0 is 1 is equal to 2R by pi, which is 4 by pi into pi. Now if you see the things carefully, this minus 4 into minus 1 is plus 4, and this 2 when it goes on to the top, it is 8 by pi square plus S is equal to again 8 by pi square. So the value of this S is 0. Okay. Because if you see, the integration is this way. So just finding the value of numerical constants from this. Clear so far? So basically the value of S is 0, which is the case here but not here. So this is the correct answer and this is the wrong answer. So only option C is the correct answer for this. Okay. So in the fight of C and D, C1 actually. Okay. Clear? Did you all understood how this is R and S? Yeah, C. Sanya, it's correct. Answer is C. We got the value of S as 0 here in this case. Okay. Subramaniam, you want me to explain once? See, it's given two equations here. F dash of 1 by 2 is equal to 2 and this integration. So we have two unknowns and two equations where two unknowns are R and S. So we found, first of all, we differentiated this function f of x, and then we found f dash of 1 by 2, from which we got the value of R. So now once we got the value of R, we substituted here and found the value of S by equating this integral to 2R by pi, which is given here. Okay, in this question. Okay, so shall we go for next question? I'm going, see here, this is the question. This is very simple question, correct? So please tell the answer. What's the answer for this question? Yeah. Still? Any different answers? Or any answers from others? C. C. Okay. Kamaluddin, C, then A. Sliva, you want to change your answers? See, in GATE examination, I want to tell you one really good thing. In GATE examination, you will be having enough time to solve questions. So please go in a step-by-step way. Okay. There's nothing in need to go in a hurry. Okay. So please see. Prasad, it's correct. Sorry, you told C. Okay, let us see whether the answer is C or not. I thought it is 2, sir. Okay, let us see. What's the answer finally, A or C? Because some of you are giving A and some of you are giving C. Okay, now I hope you understood. The correct answer is A. Okay, let us see the solution for this. Now, what's the question you have? I is equal to integral minus A to A sine power 6x plus sine power 7x dx. Correct? So this implies I is equal to, can we split this integration minus A to A sine power 6x dx plus integration minus A to A sine power 7x dx. Now, if you see, this sin x is an odd function, correct? Because I told you during the definition of even and odd functions, sine of minus x is minus sin x, correct? So sin x is some new option D. Okay, 0. So let us see here. Okay, see here. This sin x is an odd function, and since sin x is an odd function, sin x to the power 7 is also an odd function, correct? Because odd powers of negative symbol will also give you negative symbols, which means this sine power 7x is an odd function. So when this is an odd function, the limits minus A to A will give you this result as 0. Yes or no? Because since integral minus A to A f of x dx is equal to 0 if f of minus x is equal to minus f of x. Okay, so because of this reason that I mentioned you in the properties of definite integrals, this integral is equal to 0. And I mentioned one more result. What is that? I is equal to 2 into integral 0 to A sine power 6x dx. Since integral minus A to A f of x dx is equal to 2 times integral 0 to A f of x dx if f of minus x is equal to f of x. This is what I gave you. I gave you these two properties in properties of definite integrals, if you remember. Correct? So this is an odd function which is having limits from minus A to A. So this is 0, and since this is an even function, this minus A to A can be written as 2 times of integral 0 to A. Correct? So which means this complete integral is only this particular part, which is an option A. Okay. If you can understand this thing that it defined in properties of definite integrals, this question can be answered straight away, very simply. Okay, basically if it's an even function, then this minus A to A can be written as 2 times of 0 to A, and if it's an odd function, it is 0. I remember I have shown you the result for this also by considering mod x example when I am defining these things, if you remember. Correct? Whoever is attending the classes continuously, they can know these things. Clear? So far, can we go ahead? Is that okay to all of you? Okay, so I am going for the next question. Is that fine? Or if you have any difficulty, you can ask me. If you want these formulas to be written in a precise way, you can write again, which I mentioned there. F of x dx is 2 times of integral 0 to A f of x dx if f of minus x is equal to f of x, basically, and then 0 if f of minus x is equal to minus f of x. Where in this example, this is the case with sine power 7x and this is the case with sine power 6x. Okay, since sin x is an odd function. I am going for the next question. Okay. So please, shall we go? Okay, so CJ, this is the question. Evaluate this integral. exp of something means e power something. Okay, so this is basically e power minus x square by 8. Tell me the answer for this. Please solve this question, all of you. Look, I'll give you a hint here. Whenever you see integral 0 to infinity in the limits of integration, and when you have e power negative of something, could something come into your mind that we defined in improper integrals? Basically, the gamma function, correct? So, the gamma function is something like integral 0 to infinity e power minus x into x power n minus 1 dx, correct? So, if you see this combination anywhere, means e power minus of something, yes, it's a gamma, correct? So try to convert this function in terms of gamma function and evaluate the answer. If you see this combination anywhere, 0 to infinity e power minus of something, try to convert it into gamma function. Okay, and I'm happy that many of you are giving the answer as gamma. It's correct. So please try to evaluate this. I would like to give one more hint for you for the substitution so that you could carry. Put x square by 8 is equal to t. Okay, then do the question by putting this substitution. If x square by 8 is equal to t, then this is 0 to infinity e power minus t into something will come. You calculate that what is that something and try to evaluate the answer. That's why it should be continuous for lectures, because people who are attending these lectures continuously are now answering these questions. Okay. Don't feel like this is a recorded lecture, so it will be in the YouTube, so you can watch it later. But see, if you listen along with me and write the notes and all, things go in a better way for you. Okay. Later, when lectures get piled up like 50 or 60 lectures, you will lose the interest to learn the subject. Okay. So please do that. I'll be providing at the end of this lecture, Sushant. So let us, so now if you go for substitution, lower limit is 0 square by 8 is 0 and upper limit is multiplication of some infinities is again infinity. So if you write the limits, I is equal to integral 0 to infinity 1 by root 2 into root pi, which is basically from here root 2 into root pi into e power minus this x square by 8, we are approximating it as t, so e power minus t into this dt instead of this dx, since dx is equal to root 2 by root t into dt, we are substituting this and cancelling this root 2 with this root 2. Okay, now let us calculate the integral that we have. I is equal to 1 by root pi into integral 0 to infinity e power minus t into something we have here in the denominator, e power minus t into root t is in the denominator. So if you write that root t in the numerator, we have minus 1 by 2 dt. This is what we have, correct? Because this t power minus 1 by 2 is initially in t power 1 by 2 root in the denominator. So this implies I is equal to 1 by root pi into integral 0 to infinity e power minus t. This t power minus 1 by 2 can be written as t power 1 by 2 minus 1 dt. Correct? So if you see, this is the definition of gamma of 1 by 2, for which into gamma of 1 by 2, for which the value is root pi. So root pi gets cancelled. Answer is 1. Okay, so this is the answer. And I'm happy that few of you have done it correct. So please check whether you are getting the same answer or not. The answer should be 1 after this standard procedure. A is the correct answer. Okay. Which many of you have mentioned. Option A is correct. Clear so far? Any issues with this question? If you say yes, we can go for the next question. Can we go for the next question? Yeah, A is the correct answer, Nagsai. That's what we have got here after this integration. So please check. If you are okay with this, we can go for the next question. Okay. So okay, fine. Annapurna and all. See here. This is the next question that we are going to move. Which of the following integrals is unbounded? Unbounded means basically it's not finite. Bounding means it should have some finite value. Unbounded means it's going to infinity. It can be plus or minus, doesn't matter. So which of these following integrals is unbounded? B, which is integral 0 to infinity 1 by x square plus 1. Now say it's the wrong answer. B is the wrong answer. B is the wrong answer. Okay. A, C, B. Okay. Let's wait at least for 1D. Okay, because that's the correct answer actually. C, A, B. Okay, D. See here. Let me solve these four integrals. First of all, solution. First integral. Integral of tan x. What's the integral value of tan x? Option A. Integral of tan x is log mod secant x. Correct? So log mod secant x within the limits 0 to pi by 4. So log mod secant pi by 4 is secant pi by 4 is root 2. Log root 2 is defined minus log mod secant 0 value is 1. Log 1 is 0. So the value is log root 2, for which there is a finite value. Okay. Any one of 4? No. See here. B. Okay. So this is first of all integral A is log root 2, which is finite value. Correct? Now coming to B. Integral 0 to infinity 1 by x square plus 1. If you see, integration of 1 by x square plus 1 is nothing but tan inverse x. Within the limits 0 to infinity. Answer is pi by 2. Correct? Because tan inverse of infinity is pi by 2 minus tan inverse of 0 is 0. So pi by 2 minus 0 is pi by 2. You know, this is finite value. Option C, if you go integral 0 to infinity e power minus x into x dx. If you see, this is nothing but gamma of 2, which is 1 factorial, which is 1. Correct? Because this x can be written as x power 2 minus 1. So this is basically the definition of gamma 2, which is 1 factorial. So answer is 1. So which means first three integrals A, B, C are finite. Correct? Now let us go for option D. D. Integration of 1 by x. Log mod 1 minus x divided by minus 1. So if you go for this within the limits 0 to 1, when you substitute 1, you will be getting log 0 minus log 1 divided by minus 1. This is 0, definitely. But what's the value of log 0? It's not finite. Correct? Since there is base e, log 0 is infinity. Sorry, minus infinity. And there is minus sign here. So we can write the answer is infinity, which is not finite here. Okay, because this log 0 is not finite here, which is not the case similar to these three questions. These three options basically. Correct? Clear so far? Any issues with this question? So option D is not bounded. Clear? Is it okay for all of you? See, these are the three options which are finite, but this integral is not a finite value. I am writing the value of integration directly because I gave you these formulas already in previous lectures in 3 and 4. Clear as of now? Okay, so I hope now you all understood why the option is D but not A, B, C, which many of you opted for. Clear? Is that okay? So can we move ahead for the next question? Basically, better than drawing graphs, it's easy to analyze because you know drawing of graphs of these functions which are not very familiar to you is a bit complicated at this moment, okay? Because drawing the graph of x into e power minus x, then 1 by 1 minus x, 1 by x square, all these things are a bit not taught at this moment. So this is a simple way to do this question. I know many of you put for option B because you have seen the limit infinity here, but since this is tan inverse x, bounded means, Pawan, basically bounded means the integral goes to a finite value, like convergent, which we were discussing yesterday. Unbounded means the integral doesn't go for a finite value, it tends to infinity. So basically it's divergent, okay? So that's the difference between bounded and unbounded. Am I clear to you, Pawan? Bounded means finite. You can write a word here if you would like to. Unbounded means not finite. Then whenever you're looking at the notes, you can get the things. So I'm going for next question. This is 0 to x. I hope this fellow is blocking you. Okay. I gave you this question basically to show you when limits are given how to integrate the function in two ways. Integral 0 to 3, integral 0 to x, 6 minus x minus y, dy dx. See, this class will be running till 9:45, 2 hours since today is Sunday. Our next session is from 10:30 to 12:30 today itself, where we will be looking at more problems, because I know all 20 problems may not get completed within less 20 minutes. So we'll continue that problems, and then I'll give you some geometrical aspects of multiple integrals, then we'll wind up the session soon. Okay. If you are sharp enough and telling the answers quickly, we will wind up before 12:30 even. Clear? So please see. See, whoever attending these lectures continuously, they are able to answer questions now. You can see yourself in the comment box, correct? So it's not like coming for the first lecture and then it's okay taking lenience for the second lecture and all these things. Yeah, 13.5. Still, any more answers? I hope A is correct, Kamaluddin. 13.5 could be the correct answer. Yeah, Annapurna Chittui, it's correct. 13.5. Yeah. Okay. So since many of you are getting A, let me solve this question for who didn't get the answer. Solution. Integral 0 to 3, integral 0 to x, 6 minus x minus y, dy dx. Now if you see, this is the first variable of integration, dy, correct? So definitely these are limits of y, which is in terms of functions of x as expected, and these are limits of x. So if you integrate this function 0 to 3, now when you are integrating this function with respect to y, this 6 and x are constants. So 6y minus xy minus integration of y with respect to y is y square by 2 within the limits 0 to x dx. Correct? Because see, 6 is a constant, so integration of 6 with respect to y is 6y minus, when you are integrating with respect to y, you will treat x as a constant. So when x is a constant, integration of x with respect to y is xy minus y square by 2 within the limits 0 to x. So this is equal to integral 0 to 3. Now, when you are substituting upper limit in terms of y, 6x minus x square by 2 minus, when you are substituting lower limit, all these three terms go to 0 because there is y in numerator of every term. So this is 0 dx. Now I hope it's a single variable integration which you can carry out. 6x minus 3x square by 2 dx. So if you integrate this function, 6 into integration of x is x square by 2. Yeah, it's correct. Nagasai, Pavani, Livia, Hema and all. So see here, minus integration of 3 by 2 x cube is x cube by 2 within the limits 0 to 3. So if you substitute the limits, this gets cancelled 3. So 3x square is basically 27 minus, if you put 3 here, 27 by 2, which is 13.5. So 27 minus 13.5 is 13.5 is the correct answer. Lower limit is anyhow 0 because there is x in the numerator of every term. Okay. So the answer is 13.5. Basically, I gave you this question this is also a previous GATE question. It was asked in GATE exam. So I gave you this question, when limits are known to you, how to integrate the things to make you to understand the things. Okay. Are we clear so far? Can we go for next question? If someone having issue anywhere, but please be careful with this minus signs and all whenever you are doing the things. If one sign gets changed somewhere, your answer changes. Okay, so even after knowing the concepts, your answers goes wrong. So please be careful with the minus sign and all. So can we move ahead now? Can I go for the next question? All of you, please respond. See, nearly some 50 people are on live, so please tell me, can we go for next question or not? Okay, I'm going for this next question then. Please solve this question. If this is not clearly visible, this is pi by 6, okay? Integration 0 to pi by 6 cos cube 3 theta into sin cube 6 theta d theta. So please solve this question in a while. So basically, if you see, we have planned to cover this basic calculus in 10 lectures, and this is the 9th lecture that's going on. And after break that I give you, we'll meet in the next session at 10:30 today. I'll be starting my 10th lecture. We'll be solving some balanced problems and some, we'll look at some significance of table integration and all. Then we'll wind up the session for today. Okay, so this basic calculus we have dealt in 10 lectures. And if you have any doubts at these 10 lectures, you can WhatsApp me to the contact that I provided you to my WhatsApp account. And if you have any questions at any time during the course of this lecture, you can write to that mail ID or you can put it in the WhatsApp box. Okay, so please tell me the answer for this question now. Taking so much of time. So please write the things. I'll wait, I'll give you time, okay, no issues, but please try this question on your own. No answer yet. Yeah, good number of students are on live, but many people are, not answering the things. B, 1 by 15. I hope so. Let us see. 1 by 15. Okay. Still, any more answers? B, 1 by 15. Okay. Since 3 answers are 1 by 15, let me check whether this is 1 by 15 or not. Solution. Now, what's the integration that you have? I is equal to integral 0 to pi by 6 sine power 6 theta or sine cube 6 theta into cos cube 3 theta d theta. Correct? Now you know one thing. Let 3 theta is equal to t. Okay, then what this implies? D theta is equal to dt by 3, because 3 times of d theta will give you d theta. 3 times of d theta will give you dt. So dt is nothing but d theta by 3. So lower limit, since t theta is equal to 3, 3 into 0 is equal to t. So this implies t is equal to 0. What about upper limit? 3 into pi by 6 is equal to t. So this implies t is equal to pi by 2, because this 3 cancels this 6 couple of times. So see here, if you substitute all these things in this integration, we have I is equal to integral 0 to pi by 2. Now sine cube 6 theta, which means sine cube 2t into cos cube t dt by 3. Correct? So if I bring out the things a bit, 1 by 3 into integral 0 to pi by 2. See here, this sine cube 2t. Sine 2t we have a formulation. Sine 2t is 2 sine t cos t. Correct? So writing that 2 sin t cos t whole cube into cos cube t dt. So this implies I is equal to 1 by 3 into, now 2 cube is 8. I am bringing this 8 out of the integration. Now we have 0 to pi by 2 sin power 60, I mean sin cube t into, sin cube t into cos power 60 dt. I hope everything is correct so far. Yes on. So now we have a direct formula to write this integral, correct? I gave you one formula, if you remember, integral 0 to pi by 2 sin power mx into cos power nx dx. You have a formulation for this, correct? So this implies I is equal to 8 by 3 into, see, the formulation that I gave you in the other day class, I am writing it again for whoever didn't attend that lecture. So integral 0 to pi by 2 sin power mx into cos power nx dx is equal to m plus n into m plus n minus 2 into m plus n minus 4 into, means basically every alternative term and so on, into 2 or 1. Numerator could be m minus 1 into m minus 3 into and so on, 2 or 1 depending upon m is even or m is odd. Similarly, n minus 1 into n minus 3 into and so on, 2 or 1 depending upon, again n is even or odd, into k. Okay, let me write this into with a proper sign, into k, where k is equal to pi by 2 if both m and n are even. If both m and n are even, 1 otherwise in the sense if m is even and n is odd, or if both are odd, in that cases the value of k is 1, but if both are even, the value of k is pi by 2. This property I have already given you when I am teaching the introduction of definite integrals in the properties of definite integrals. Okay, so if you apply this result now here, this is integral 0 to pi by 2 sin power mx into cos power nx dx form. So if you write things carefully, m plus n, 3 plus 6 is 9. So 9 into 7 into 5 into 3 into 1. Okay, this is what we have. Now m value is 3, so m minus 1, 2 into, that's it. We can't go for 0. Next, here there is 6, so 5 into 3 into 1. This is what we have here. Into, now here 3 is odd and 6 is even. So which means out of m and n we have one odd number which is 3. So the value of k is only 1. Okay, so now simplifying the things, this 5 gets cancelled, 3 gets cancelled, and I hope that's the calculation that we can do here at maximum. So is there still something that we can cancel here? 8 by 3 into m plus n, 9 into 7 into 5 into 3, 16 by 189. Is that the answer coming? Did we make any calculation error here? 0 to pi by 2, t is equal to pi by 2 then? Yeah, t is equal to pi by 2. Everything is from pi by 2. Cube, 2 cube is 8. So sin cube t into cos power 60 dt. Okay, so if there is 3, then there is 6 here. 5 into 3 into 1. 2 by 9. So if you simplify the things, 2 8s are 16 divided by 27 into 7. 27 into 7 could give you 189. So this is the actual answer for this. Okay, 16 by 189. So I think there is this 8 by 3 into something. So you can change this answer as 16 by 189. Okay. So this is the correct answer. So basically when given the options, I think we have forgotten this bracketed term and this 8 by 3 as it is we have kept here. So please correct this. 16 by 189 is the correct answer. Okay. So I hope now there are many 16 by 189 because of no option being there. I think you people have been misguided. So please look at the things clearly. Okay. This particular step, Subramaniam, you want me to explain again? See here, this is the formulation that I gave you for this formula. Now put m is equal to 3 and n is equal to 6 and write this expression. You yourself will get the answer. Okay. This I gave you doing properties of definite integrals and later that. So please see here. Okay. So I am going for the next step. This question. Okay. This is a table integral. We'll visit later. As of now, we didn't talk about this. But still you can solve this question if you want to. Shall we solve this question now? So that you will get an idea how to solve a table integral question. Shall we solve it? Now itself we can solve with the knowledge that we have from definite integrals, double integrals. Okay, so we'll solve now. See here, solution. Let me shorten this question a bit, so I'll be getting some space to write the steps. I hope you can still read the question comfortably, no issues. So see here, I am solving this question now itself. Solution. What is the volume of the solid given? V is equal to integral 0 to 1, then 0 to pi by 3, then 0 to 2 pi. R square sin phi dr d phi d theta. Now, which limits are of which variable? That's the main question. Okay. Now we have three integrals and we have different limits on the three integrals. Now if we can judge which limits are of which variable, then we can solve this question. See here. What's the first variable of integration here? R. So these are the limits of R. Similarly, the second variable of integration is phi. So phi is equal to 0 to phi is equal to pi by 3. And finally, these are the limits of theta. So theta is equal to 0 to theta is equal to 2 pi. Now let us perform the integration. Since all these are constant limits, no issues. Now, since the first variable of integration is r, we'll treat phi and theta as constants. That's what I told you. Whenever you are treating this r as the first variable of integration, you will treat all of the phi and theta as constants, which means if you are treating phi as a constant, this sin phi is also constant. Correct? So let me evaluate this. V is equal to integral 0 to 1, 0 to 2 pi, then integral 0 to pi by 3 into, now integration of this r square is r cube by 3 within the limits 0 to 1 d phi, we have sin phi again here. So sin phi into d phi d theta. Correct? So now if you substitute v is equal to, if you substitute this 1 and 0 here, you have 1 by 3 which is a constant. So bringing out that 1 by 3 constant, we have integral 0 to 2 pi, integral 0 to pi by 3 sin phi into d phi d theta. Now integration of this sin phi is minus cos phi. Correct? So v is equal to 1 by 3 into integral 0 to pi 2 pi. Now integration of this sin phi is minus cos phi within the limits 0 to pi by 3 d theta. Correct? This is what we have. So this implies v is equal to 1 by 3 into integral 0 to 2 pi. Now this 60 if you put here, pi by 3 is 60, so cos 60 is minus 1 by 2. So minus of 1 by 2 minus, then cos 0 is 1 d theta, which means now you have v is equal to 1 by 3 into integral 0 to 2 pi. See here clearly, this is minus of 1 by minus 1 by 2, which is 1 by 2. So we can write 1 by 2 d theta. So now v is equal to, this 1 by 2 is a constant, so 1 by 6 into integral 0 to 2 pi d theta. This is equal to 1 by 6 into integration of d theta with respect to theta is 2 pi. So theta, so we are getting the answer straight away as pi by 3. So volume of this solid, volume of the solid is equal to pi by 3. That's what we can conclude from here. So basically, when evaluating table integrals, you need to know what are the limits of integration. Basically, okay. In any multivariable integration, the main art is to know which limits are of which variable. If you know that, then you can perform the integration by considering all of the variables as constants in successive steps. Am I clear with this particular question? Am I clear with this particular question? Did you all get pi by 3? Okay. Okay. So we'll move for next question before going for break. See here. One last question. Could you solve this question? Both limits are from 0 to pi by 2. Once we solve this question, we'll go for a break. So please tell the answer. What's the answer for this question? Okay, I'm happy that all of you are understanding the things. So please solve this question. We'll go for next. Okay, so from Monday, from tomorrow, I am starting this thermodynamics course for mechanical engineering students. Timings, I'll let you know by the end of this video or tomorrow video. So you can attend thermodynamics as well, while from mechanical. Okay, we'll look at good concepts of thermodynamics and then we'll solve gate questions in a similar way. D is the answer. 2. Any other answers? Sliva told 2. B. Sarath told it's B. Pi. Okay. Let me see. Someone go for A and C as well. D. Kushvardhan, you're telling it's D. Okay. Let me solve this question since we have left with only 2 minutes for the break. So see here. Solution. Integral 0 to pi by 2. Integral 0 to pi by 2. Sine of x plus y. If you see, this first variable of integration is x. So which means these are basically limits of x and these are limits of y. So what is the formulation for sine x plus y? Sine x cos y plus cos x sine y dx dy. Okay. So your first variable of integration is x. So whenever you are integrating with respect to x, you will treat y as a constant. Correct? So this is equal to integral 0 to pi by 2. Now, treating y as a constant, okay, is it audible to you? Okay, see here. So treating y as a constant, please integrate this function with respect to x. So if you do that, cos y into integration of sin x is minus cos x plus cos sin y is again a constant. So integration of cos x is sin x within the limits 0 to pi by 2 to this whole dy. Okay. So this is equal to integral 0 to pi by 2. See here. Now, when I am substituting the limits, cos y into minus, okay, let me take the minus sign common. Cos 90 is 0. Minus cos 0 is 1. So this is what we have here plus sin y into, again, sin 90 is 1 minus sin 0 is 0 within the limits of integration dy. So this is equal to integral 0 to pi by 2 minus of minus 1 is 1 cos y plus sin y dy. Now I hope you can integrate this function. Let us integrate this. Mohan Dev Gandhi, you came now? Okay, I'm happy at least. Integral 0 to pi by 2 sin y plus cos y dy. So if you integrate the functions, integration of sin y is minus cos y plus integration of cos y is sin y within the limits 0 to pi by 2. So if you substitute for cos pi, if you substitute minus of cos pi by 2 is 0 plus sin pi by 2 is 1 minus of minus cos 0 is 1 plus sin 0 is 0. So which means 1 plus 1 answer is 2. Okay. So basically this option D is the correct answer, which many of you are telling. Okay. Yes, I'm happy for you, Sarath, Hiranmai, Pavani, Maunika and all. So it's 9:46. We'll take a break now for 45 minutes and we'll meet again at 10:30. We have another, some 10 very good questions to solve, which we complete after which we deal after the break in the second session, and also we'll go for some geometrical aspects of multiple integrals. Okay, so please go and come back at 10:30 live again sharp. We'll solve these questions. Okay, is that clear to all of you? We'll have a second session today at 10:30 after 45 minutes from now. Clear?